Going to the sort of automated integration and some of the abilities that you're exposing through these next sets for being able to say, this is my source data set, this is how I want it to end up, and then being able to generate the transformations or generate the logic that so that the user doesn't have to handle that. That's where a lot of the challenge comes in for data practitioners is I have this source data, I need to be able to transform it in such a way that I'm either not introducing my own sort of bias or my own interpretation of this information, or I'm not going to create a lossy transformation that prevents me from being able to actually answer the question that I was aiming for. And so I'm wondering what you have found to be some of the useful heuristics for being able to interrogate the source system to say, what is the data? How is it stored? What is the schema? How am I going to be able to actually generate these transformations to answer the question that the end user is asking for or present the data in the way that they're looking to send it on to another system, and just some of the ways to be able to actually encapsulate and hide some of that complexity from the end user.
Actually, in that point, we actually again go back to the fact that within an organization, there'll be people of different skill levels, right? So, when we think of our connector, there's a very advanced mode where you can configure many, many things into it and literally connect to anything. But that converts into a template, right? So if I have configured that, hey, this API is OAuth 2 and it is three-legged OAuth and it has a pagination of this style. And if you call this API and pass its data to that API, then you will get this result. If I have, put all of that and configure that in Nexla, that can become something that's pre-packaged for the next person. They can just come and click on a button and go with it. So from a heuristic, I think more of it also comes from just like, how will people work together, right? And how will the person who knows a problem solve it once, but then it becomes a solution forever, right? At some point we'll make this community capable as well, where you can share what you have discovered or built in the broader community. So that's a big part of the heuristic that comes in. From a very technical perspective, I think there are definitely things that we have seen, as far as like schema management and stuff, like what can you do, when you start seeing more data, you see slight changes in the structure or the the attributes and, stuff like that, and how we've done like even simple unions of schemas can give you some very interesting results. Of course, we do more advanced match of schemas and overlaps and stuff, but some simple heuristics can go a long way.
And then another interesting aspect of these logical units of data that you're building with the next sets is the idea of being able to compose them together or do further refinements of an existing data set. And I'm wondering how that plays out in terms of being able to say, I've got this next set over here where I'm pulling data from a Postgres database and presenting it as a Parquet file in S3. And I've got this other one where I'm pulling data from a Kafka stream and I'm presenting it as an API, and I now want to take those two and I want to put them together and get a new next set out of that.
There are a couple of very interesting concepts there. The core concept is that a next set plus code or logic creates a new next set. So you take a next set, you transform it, the outcome is a new next set. You could give somebody access to that. Then they could do their own transformations, filters, enrichments, whatever, and get a new one and a new one and a new one. So that's kind of one sort of aspect, which is a linear. The second aspect is like, okay, combine 2 or 3 next sets together. We see this all the time with some of our customers. Take the product next set, take the inventory next set, take the price next set by store, combine that all into a single entry. There is a concept of looking up from one next set to another, just like in Excel, you have like a VLOOKUP, for example, you can do a lookups across next set. You can look into that. We have the underlying mechanics to, hey, if the data is a stream, then appropriately cache it. So you can do very fast lookups on that. We'll soon be introducing this concept of like even SQL joins and stuff like that on that. So there will be more things coming, but yes, it does make it possible for someone to say that in order to get the outcome that I'm looking for, I can create more derivatives or at any stage pass on to somebody else who might be the right person to do it.
And I think this is fundamentally possible because of having an open entity which is composable, right? So as you said, if you get data from Postgres and you get data from S3, currently, if you have to do it, you'll end up writing a lot of integration code and exposing something on top of this. But when you do this with Nexla, you're able to get 2 net sets, join those 2 net sets, and you have like 7 different ways of accessing that net set out of the box.
We had a very interesting use case. There was a freight broker that was getting emails from drivers, and that email would have an attachment of their driver license or insurance policy, and their goal was, hey, can we validate this driver and onboard them onto the platform, right? So they made these emails as sources in our system, and the first next set that would detect with the email would have the attachment pointing to that, and then it would detect some tables inside the email if they have that and stuff like that, right? That next set then was enriched by making calls to some OCR systems and say, okay, from that image, what other information can we grab? So the resulting next set after that sort of processing or the enrichment stage with some external services had a lot more data from those documents. And then they had the logic to say, oh, is the driver license valid? Is the insurance policy large enough, or whatever they had the criteria? And then the outcome of that next set was piped is an API into their system. So they were able to say, okay, from now we are able to onboard like 80+% of the drivers automatically. And then where you didn't make that confidence score from the result, they could pipe the outcome of that next set out into a spreadsheet that ends up in the desk of an ops person who will manually approve or disapprove, right? So we find people come up with some extremely compelling and interesting applications by composing these next sets together along with other third-party applications or systems they have.
And then for the situation where you might have two different next sets and you only want sort of half of the information that each of them are presenting so that you can combine that in a different way for a third next set, do you have a way of being able to sort of optimize the execution so that you don't have to run both source next sets to their completion and then take that output as input to the third one, where you can say, okay, well, I see that I'm pulling data from Postgres and S3 for this next set over here, and over here I'm pulling data from Kafka and an API, but I actually only want the data from S3 and the API, so I'm only going to make those calls for this third next set when people request it.
So the execution plan of the net set is tweakable. So you can say, I want this net set to run in A execution engine. I want to run another net set in B execution engine. There is a windowing concept that you can apply on top of a stream, for example, in this case, and be able to get a net set almost immediately out, right? So from a perspective of the underlying streaming and the real-time architecture, you are able to do things like these fairly easily.
I would say that, some of these use cases that you mentioned, sometimes you also recommend to people that, hey, it may be okay to materialize an next set into some system, then use it, and then make that as a source, and again, make a new nexus. So I'll give an example, right? You get data from 3 different systems, and you're trying to do something complex, and you're like, you don't want to force fit a solution, right? So you can say, okay, these 3 nexus, I'm going to materialize, say, in a database, right? Or data, and then I'll do some, ELT sort of transforms in there or whatever, and then make that outcome a next set and then take it further downstream. So sometimes problem solving in computer science and software is always like you can solve the problem in 5 different ways. One of the ways, as Avinash is saying, and I'm like, maybe that will be too complicated for a user to figure out. And sometimes you can break it down into a few linear steps and do that. So yeah, there's never one right answer in some of these use cases.
Yes, the correct answer in computer science is always, it depends.
Depends, yeah. People ask me, it's like, oh, is this the modern data stack? I'm like, no, there's no one solution that fits. Yes, you can do ELT and it makes a lot of sense, but no, it's not an answer for everything. I remember the question people used to ask, like, hey, is Java the programming language that will be there? And then everything else will be gone. And of course, over time, like, no, more programming languages will come, and it depends. It depends what problem you're solving. So I would say the same thing with data solutions as well.
And in terms of the ways that you've seen the Nexla platform used and some of the next sets that have been created, what are some of the most interesting or innovative or unexpected applications of the technology that you've seen?
Using that, email attachment is a very interesting one. We had a large financial institution use, S1 filings, which are publicly available as a data source, and our system could take care of, fetching the data, handling the rate limits and all of that stuff, and even detecting some tables in those documents. And then they could focus on, their machine learning service that could take that unstructured document and spit out more sort of, identifiable, entities or features for them, right? And we felt like, oh, that's a very interesting way to use it, because it's accelerating them and their roadmap and reducing their dependency on software engineering. So yeah, we do routinely come across some very interesting use cases.
Business use cases like a shipping broker, multiple e-commerce companies working with different shipping brokers. Each one of them have built their tracking systems in a slightly different way. Now, an e-commerce company to integrate with all of those is going to be a nightmare. It's probably a 5-year project. But when you have something like Nexla in there, you get net sets on the inside, you get net sets on the outside, and you can orchestrate all of this with a single API call, irrespective of who the data is coming from, who the data is going to. So things like these, we didn't originally intend that this would be used in this particular way, but when we see this, like, oh, it makes all the sense. You're able to get one net set on the input, another net set on the output, your one API call, you're solving a business problem in a matter of days for things that would have taken you years to do.
And so for people who are looking to improve the overall operability of their data and streamline some of their processes, what are some of the cases where Nexla might be the wrong choice?
We would like Nexla to be the right choice whenever you are working with data, of course. We always clarify to people that, look, we're not a BI or an AI tool. Our job is to bring the data to you. There are many aspects of it, right? I mean, data is a very broad space, okay? For example, as I mentioned, we do monitor the data, as we're sitting in the flow. We're not going to say that we're going to solve all your data monitoring challenges. What we do best is we generate so many signals that you can consume in your Datadog or your favorite monitoring tool and do it there. So our goal always is we don't want to reinvent anything. If something is there, we want you to connect with it. We want to power it, right? So we certainly, that part. As I mentioned, we do run SaaS, but also offer like on-prem options. So if you're running on-prem and you want to do this one-time data migration, I don't know if you really want to take and bring in and get the security approval to deploy a system for one-time use case. So there are definitely cases where, you have to think about, hey, is this technically the right solution? And then you have to think about business-wise, does this, make sense? But I think we cover a very broad set of use cases extremely efficiently for companies.